This is questions of a system of linear equation, 3 variables. The questions are from, again, Nicolaides, Christos Nicolaides teacher. So let's go from number 9. System equation is formed like this, and we need this unique solution. So unique solution means one x, y, z set. So here, non-unique solution means 0, like no solution, or infinite solution. So now let's go for it. 1, 2, k, 0. 1, 3, 1, 3. K, 8, 5, 6. So the first, we need to eliminate here to make it 0, make them 0. So first and second line, I will subtract them together. This is the operation row by row. So 1, 2, k, 0. When I subtract them, so 1 minus 1, 2 minus 3, k minus 1, 0 minus 3. And the last one, this is k. To eliminate it, I need to make some other, to make it, anyway, again, this also make the row operation with the other rows. So here, I'll make it k, 3k, k, 3k, and subtract them. So 0, 3k minus 8, k minus 5, 3k minus 6. And now I need to eliminate here. So 1, 2, k, 0. 1 minus 1, k minus 1, negative 3. So there, I will multiply 3k minus 8 to the second row. So what 0, negative 3k plus 8, 3k minus 8 times k minus 1, negative 3 and 3k minus 8. Let me simplify a little bit further. Negative 3k plus 8, 3k squared, negative 11k plus 8, negative 9k plus 24. So now from here and here, we can add them together to remove the second element. So 0, 0, 3k squared minus 10k plus 3, and negative 6k plus 18. This is how we get what we get. So this for the unique solution. Now this is the meaning of 3k squared minus 10k plus 3, z becomes negative 6k plus 18. Let me do some factoring. 3k, 3, like this. So z negative 6, k minus 3. So if we want to have any unique solution, we need to make the z equals negative 6, k minus 3, 3k minus 1, k minus 3, and like cancel them out, something like that. But here, we can, how can I say? We can find z only and only if 3k minus 1 is not 0 and k minus 3 is not 0. We cannot divide anything with 0. So 3k minus 1 cannot be 0, k minus 3 cannot be 0. So the answer for the question A is k equals 1 over 3. I mean k is not 1 over 3, or k is not 3. And number B, non-unique solution. In this case, find the solution set. Actually, here, if this is not non-unique solution, there are two different cases. When k is 1 over 3, when k is 1 over 3, only left side is 0 and right side is not 0. K 1 over 3, in this case, no solution. And the second case, when k equals 3, actually this is 0 times z equals 0, which makes it infinite solution. So when it is infinite solution, we can express the solution with like general expression. So let's start from here again. Now k is 3. 1, 2, 3, 0. 1, negative 1, 2, negative 3. 0, 0, 0, 0. So from here, from the second line, negative y plus 2z equals negative 3. So now let z be t. Usually we set z as t. So y becomes 3 plus 2t. And from the first line, x plus 2y plus 3z equals 0. Therefore, x equals negative 70 minus 6. So the solution is x equals negative 6 minus 70, y equals 3 plus 2t, z equals t. So what this means, that whatever you input, which number, any number you put into t, you get the solution sets. For example, negative 3, negative 6, 3, 0 is the solution. And negative 13, 5, 1 also solution. Something like that. That's why it is infinite solution. And let's go to number 10. So this is the unique solution. Show that this has a unique solution when a is not negative 1. So 1, 3, negative 1, 0. 3, 5, negative 1, 0. 1, negative 5, 2 minus a, 9 minus a squared. So let's start. 1, 3, negative 1, 0. Let me make the first line like multiply by 3. 9, negative 3, 0. And subtract them with the second line. 0, 4, negative 2, 0. So, and for the third line, I will calculate them together with the first line. So from the first, I will subtract the third line from the first. So 0, 8, negative 3 plus a, negative 9 plus a squared. And from here, to make this 0, 1, 3, negative 1, 0, 0, 4, negative 2, 0, 0, 8, negative 4, 0. So 0, 0. Negative 1 minus a, 9 minus a squared. So when a is not, this means negative 1 minus a, z becomes 9 minus a squared. So when a is not negative 1, then z becomes 9 minus a squared over negative 1 minus a, which defines. So therefore, unique solution. This simultaneous equation has a unique solution. And number B, state the solution in terms of A. Okay, so let's do that. When A is not negative 1, then unique solution. When A equals negative 1, then 0z becomes 8, which is no solution. But there's no other options. I mean, because without this doesn't, this is not the important condition. When this becomes 0, and this is not 0, for example, and or this is 0, something like that. So the combination of this and this make the meaning of the for the solutions. But when this is not 0, this doesn't mean anything. So there are only two conditions: when a equals -1 or when a equals -1. So number C, hence solve. So in this case, a equals 1. So let's go for it. When a equals 1, then z becomes -2 and 8, which is -4. Second line, 4y minus 2z equals 0. So y equals -2. And the first line, x plus 3y minus z equals 0. So x equals 2. Therefore, x equals 2, y equals -2, z equals -4. We need to find all together. And number D, investigate the case. No, I think this is the answer for number D. Now I understand what it is asking. So this was the answer for Z. So solution in terms of A, oh, this is very, we don't want to do that, but what can we do? So here, the second line, it was 4y minus 2z equals 0. So 4y equals 2z, y equals half z, and this was z. So -2 minus 2a, 9 minus a squared. This was y. And x 3, -1. X plus 3y minus z equals 0. So x should be, -3y plus z. So -2 minus 2a, -27 plus 3a squared plus z. 1, okay. Anyway, that is the half of a, 9 minus a squared. So -2 minus 2a, -27 plus 3a squared plus 18 minus 2a squared. So -2 minus 2a, -9 plus a squared. So this was x, y, and z. Therefore, x was -2 minus 2a, -9 plus a squared. Y, -2 minus 2a, 9 minus a squared. Z, 9 minus a squared over -1 minus a. That's why number C was when a equals 1. So x becomes -4, -8, 2. Y becomes -4, 8. I didn't know. -2. And z equals -2 and 8, which is -4. Oh, was it? Yes, it's the same answer. So this was the answer. And number 11. So x, y, z is like this. And show these equations do not have a unique solution. So just to note the condition once more. So when we make this matrix and goes until the end for our steps, the last row always with the 2 zeros the beginning, and there are another 2 more numbers like this. So if a is not 0, actually it means this simultaneous equation has unique solution. And when a equals 0 and b equals 0, then 0z equals 0, which means infinite solution, because any z can be answer. And a equals 0, but b is not 0. So 0z cannot be 3, let's say, because z is already multiplied by 0 and it becomes 0. So this one has no solution. So this is just a general explanation. So let's go for number A. 1, 2, 1, k. 2, 1, 4, 6, 1, negative 4, 5, and 9. 1, 2, 1, k. 2, 4, 2, 2k. Yeah. Yeah. Let me go for the last one because I just try to avoid the k. 2, negative 8, 10, 18. So 0, 9, negative 6, negative 12. And between number 1 and 3, 0, 6, negative 4, k minus 9. I will make the second line, like I'll divide by 3. 0, 3, negative 2, negative 4, just to make the number smaller for easier calculation. And I'll multiply by 2 here to calculate it with the last row. 0, 6, negative 4, negative 8. So 0, 0, 0. And k minus 1. So whatever it is, since this is 0, therefore this is simultaneous equation doesn't have a unique solution. Non-unique solution. And I find the value of k consistent. Consistent means a solution, like a unique solution or infinite solution. Whatever it has any solution, we call it consistent. So at this moment, we already know we don't have any unique solution. So we need to go for infinite solution, which means 0z becomes k minus 1. So k should be 1 to make it 0z equals 0. So 1, 2, 1, 1, 0, 3, negative 2, negative 4, 0, 0, 0, 0. So again from, so I'm solving for number B. So start from the second row and let z equals t. 3y minus 2t equals negative 4. Y is negative 4 plus 2t over 3. And x plus 2y, 2y plus z equals 1. So z 3, 3. So 11 over 3, negative minus 70. So x. Therefore, x equals 11 minus 70 over 3. Y equals negative 4 plus 2t over 3. Z equals t. So this is the answer.